So today we're going to look at the homework solutions for yesterday's homework, 330. It tells us to find the test statistic. It's a Gallup poll on job satisfaction. The claim is that more than 75% of workers are satisfied with their job. And simple statistics include 580 employed adults, with 516 of them saying they're satisfied with their job. First thing we're going to do, write down what we are given. Write down the info. So N is 580. That's how many were surveyed. Now, P hat is how many said they were satisfied out of the total. And I'm going to go ahead and write down my null and alternative hypotheses. Even though we're not doing a hypothesis test, I still need to know what we're looking at here. So the claim is that more than 75% of workers are satisfied. Well, that's more than, so that's going to be right here, and that's a proportion. And I'm going to put that as a decimal. So that would be my alternative because more than does not include equality. So it's greater than 0.75. That goes in your alternative hypothesis, H1. Less than or equal to would be your null. They're always opposites, complements of one another. Now it tells us to find the test statistic. So I'm going to grab my formula sheet if you don't know the formula off the top of your head. Look down here on the second page, right here. Take a screenshot of it. And there's the formula we're going to use. So let's see. Okay, we've got P hat. This is P. P is 0.75. Now we also need Q, not Q hat. So I don't need to bother with Q hat, but Q is going to be 1 minus 0.75, which would be 0.25. So now we have P hat, P, Q, and N. We got all the things we need. We just need to plug them in, and we're done. So my test statistic is equal to P hat minus P over square root P times Q over N. And 580. Now grab your calculator. Doesn't matter which one you use. I'll use the Casio first. I got a fraction inside of a fraction. Just type that in there. Square root in the denominator with the fraction. And our test statistic is 7.76, or 7.77, why not? So remember, the test statistic is your number of standard deviations away from your mean. This is only 8 standard deviations away, so this is an extraordinarily unusual value. It's extremely high, so yeah. If we were testing the hypothesis, we could almost guarantee that it would be, more than 75% are satisfied. Now, if you're using a TI, even though it doesn't ask you to do the full hypothesis test, you could still use the hypothesis test to get your test statistic. So if you go to Stat, Tests, this would be a one-prop Z test, number 5. P, okay, so that's our 0.75. That's the actual P, not P hat. It says P naught. X, so that's going to be our 516. N is 580. Now, it doesn't matter which tail we use because all we care about is the test statistic, but why not make it match? And here we go. Here's our test statistic, 7.77. It also gives us our p-value of a decimal followed by 14 zeros and a 4. So pretty much any alpha you can throw at it, it's going to be smaller than that alpha. And yeah, there's p hat, that is a decimal, and n. So you could also just type this in the TI. It'll still pop it out for you as long as you use proper parentheses. Look at the next one. It just says, write the conclusion. This is one of the most important parts of the hypothesis test, is your conclusion. There's 4 different scenarios. If you haven't watched the previous video, go back and watch it, pause it, write them down, memorize them. So the claim, the proportion of red M&Ms is different from 0.13. Let me write down my hypotheses. H0, H1. Again, you can use HA if you want to. It doesn't matter to me. Different. That means not equal to. So P is not equal to 0.13. So anytime we have the not equal part, either less than, greater than, or not equal to, that goes in your alternative. So that's how I knew where to put this one. So P equals 0.13. That's the null. Now, where's our claim? Our claim is here in the alternative. And it says we fail to reject the null. So if we fail to reject the null and our alternative is in the claim, then there is not enough evidence to support the claim that. And then we write our claim. The proportion of red M and, I'm going to do this, M's is different from 0.13. That would be the conclusion. Let me go back to that chart. It shouldn't be too terribly far. There it is. So our claim was in the alternative. We failed to reject the null. That means there is not enough evidence to support the claim. You need to know this. This must be memorized. There's 4 different cases. You got to know each one. Okay? So I guess I can change this to an ampersand. There. That would be the conclusion. So the next one's hypothesis test, full test, but it walks us through it. Part A, B, C. We're not going to do C, actually. That's what we're going to learn about tomorrow. So p-value again, we're going to learn about that tomorrow, so we're not going to answer it here. And then it asks for the conclusion. So let me go ahead and write down all my info. In one of Mendel's famous hybridization experiments, 8,023 offspring, there's my N, were obtained. 24.94% of them had green flowers. So P hat, that's our sample, is 24.94. Let's just see if we can write that as a number over 823. If we can't, we're going to have to round on the TI. And we need a percentage. So. Okay, so we're going to have to round on the TI to 2001 over 8,023. We'll get there in a bit, though. So there's P hat, there's N. Consider the hypothesis test uses 0.05 significance. That's alpha. To test the claim. Okay, there's my claim. That green flower peas occur at a rate of 25%. So let's look at it. The claim is that they do occur at exactly 25%. That's an equal to. So let me write down my hypotheses. That has equality in it. That's going in my H naught. P equals 0.25. So my alternative would be a not equal to. Either way, my p-value, the population proportion, is 0.25. That makes Q 0.75. Now remember, whenever we're doing this, you need to make sure the conditions for approximating the binomial with the normal distribution are satisfied. 25% of 8,000, that's definitely bigger than 5. And on this one, well, they didn't even tell us, so we assume it's good. They did it. So remember, test your conditions for binomial. Again, I'm not going to have any that aren't doable on this one. If they give it to you, it's good. So, yeah. Conditions check out. Where were we? We need to find the test statistic for part A. So, part A. Let's get this test statistic. Same formula as before. P hat minus P over square root of PQ over N. So that is P hat. Okay, I wrote this incorrectly, didn't I? That's a percentage, so let me make sure I write it as, oops, decimal. 0.2494. So whenever we're doing with these, we always want our decimals. We don't want percentages, convert them. So 0.2494 minus P, we said was 0.25. Square root P times Q and N was 8,023. So I'll do this first on the Casio. 0.2494 minus 0.25. Square root fraction, 0.25 times 0.75 over 8,023. And we get a test statistic of negative 0.124. Now I'm going to go 4 decimal places. Negative 0.1241. The reason I want to go 4 decimal places, usually these scores, or the critical values, are rounded to 2 decimal places. A few of them are rounded to 3 decimal places. So if we go 4 decimal places, we'll definitely be safe and know if it's bigger or smaller than our critical values. So for part A, we're done. For part B, it asks for the critical values. That's where we deal with alpha. Let's look at what kind of tails we have. This tells us, our alternative tells us, it is a 2-tailed test. So the alternative tells us our tails. This one's a 2-tail. The 2-tail, we have to split alpha in half. Instead of 0.05, we're going to use 0.025. So for B, let's see. So for B, I'm going to use alpha as 0.025. I'm going to do it all 3. Look it up on the chart. 0.025. Where are you? 1.96 if I remember. Yep, right here. negative 1.96. Since it is a two-tail, we need both the positive and the negative. Negative 1.96, positive 1.96. Using the Casio. .025, just going to do an inverse normal, negative 1.96. There you go. Just remember, if it's a two-tail, you need both the negative and positive and to split alpha in half. If it's a left tail, you don't split alpha in half and just use the negative. Right tail, don't split alpha in half, use the positive. Okay, and I'll do all this again on the TI at the end. Okay, C tells us to write, well, C tells us to find the p-value, which we're not doing this time. We're going to do that next time. D tells us to find our conclusion. What do we conclude? Well, in order for me to do that, I need to see it. I need to draw it. So that's what I'm going to do right now. Sketch my curve. Here's our median. And our boundaries are plus or minus 1.96. And our critical region, our rejection region, is outside of those boundaries. So anything in this shaded region, we'd reject the null hypothesis. Let's see where our test statistic is. Let's see, it was negative 0.124. Well, that's definitely less than 0, but greater than negative 1.96. I'm going to stick it right there. Negative 1241. Since the critical value is not in the rejection region, we're going to fail to reject the null. The null. Okay. Let's go back and read our claim. The claim is that the green flowered peas occur at a rate of 25%. That's got equality in it. That means this, our null, is our claim. It's different. No, it works. So our claim was in the null. We failed to reject the null. So our answer for the conclusion would be there is not enough evidence to reject the claim that and whatever it said. Let's see, what did they say? Green flowered peas occur at a rate of 25%. So that'll be the conclusion. Again, you have to know that chart. If you don't know that chart, you won't be able to answer the conclusion. You'll get 0 points on your final. So there's not enough evidence to reject the claim that green flowered peas occur at a rate of 25%. We failed to reject the null. Claim was in the null. Not enough evidence to reject the claim. Okay. I said I'd do this on the TI, so let's do it on the TI. So instead of typing all this in for the test statistic, I just run my one prop Z test to begin with. But I do need to round, so I get a slightly different test statistic. And Jared, can you come to this on my class? I'll get 10 after I do this video. 2001 out of 8,023. And then stats, one prop Z test, that's number 5. P was 0.25. X, that's our 2001. That's the number we just got. We did our percentage times N. and we had to round it. We had to round a whole number for these because it is binomial. So it doesn't make any sense to have 8/10 of a pea plant. 8,023, I think. Yeah. Now, look at our alternative. Not equal to. That tells us what we're dealing with here. We always use our alternatives to look at our tails. And we get negative 0.122 for negative 0.1225 for our test statistic. Very close. Again, doesn't matter to me which way you do it. I'll have a acceptable range of answers depending on if you use the TI or the Casio. But it also gives us our p-value. And if you remember, we could do the p-test, which we're going to learn about next time. And it does say if p is greater than alpha, we fail to reject the null. So it's a lot easier on the TI to do a p-value test. But we're not doing a p-value test today, so let's go ahead and get, there's our test statistic. Let's get our critical values. Again, we're going to do an inverse norm to get the critical values, 0.025, and it's standard normal, plus or minus 1.96, and the rest is the same. Draw it, shade it, plot it. Fail to reject the null, not enough evidence to reject the claim. Okay, next. Gender selection for boys. The Genetics and In Vitro Fertilization Institute conducted a clinical trial of Y-sort method designed to increase the probability of conceiving a boy. As this book was written, 51 babies were born to parents using the Y-sort method, 39 were boys. Use the sample data with a 0.01 significance level to test the claim that with this method, the probability of a baby boy is greater than 0.5. Does the method appear to work? Okay, so start off, we're going to write down our info, and hey, here's the claim. So, in 51 babies, P hat, 39 of those 51 were boys. So for you TI users, you're going to use 39 for your X. We don't need Q hat. Let's write down our hypotheses. Oh, well, alpha. We can go ahead and write that. 0.01. So we've got our null and our alternative. Let's read the claim again. They was greater than 0.5. So that's going to be proportion greater than 0.5. Doesn't have equal to in it. That makes it go in the alternative. And I'm going to go ahead and make a note. That's where my claim is. The null is a complement of that. Okay. So I think we have all the info we need. Well, we can go ahead and write down P and Q. Both of them are going to be 0.5. P is 0.5, so Q is 0.5. And now we're going to go, we're basically going to do the same steps here, but this time instead of telling us find a test statistic, find a critical value, what's the conclusion, it just says do it. So we got to do what we got to do. If you don't know the formula, look it up on your formula sheet. It's P hat minus P over the square root of P times Q, not P hat, over N. That gives us our test statistic. Again, I'm going to use a Casio first. Go back to mode 1 so you can type stuff in. Just type this number in the calculator. I know 0.5 times 0.5 is 0.25, so just type it in there. 3.78. So that's my test statistic. And again, I'm going to go 4 decimal places, 3.7808. Oops. 2 should be sufficient, but 4 will definitely cover us. Now I'm going to get my critical values. Well, Alpha is 0.01. It's a right tail. So we have a right tail, thanks to our alternative telling us it's greater than, so it's a right tail. That means we're going to look up alpha, not cutting it in half, and use the positive. It's 0.01. So that's going to be close to here. Wait, where we go? So here's 0.0107. This one's slightly further away, so we're going to use this one. 2.30. We use the positive. So our critical values are, I'll call it V-crit, 2.30. Just use an inverse norm. Oops, don't know what I hit there. .01, 2.33. Let me look back on the Z-chart then. 2.33. Oh, wow, yeah. So I'm blind. There it is right in front of me. It's a lot closer. So we're going to use 2.33. Sorry about that. And that's what we're going to plot. So draw it. There's our 0. Our critical value, 2.33. The rejection region. So if it's in this region, we reject the null. And guess what? 3.78 is bigger than 2.3. So yeah, we're going to reject the null. So we reject the null. Now we can write our conclusion. Let's see. The claim is in the alternative. We rejected the null. So our conclusion would be there is enough evidence to support the claim that with this method, the probability of a baby being a boy is greater than 0.5. Boy, not buoy. I can just find that a little nicer. There we go. There is enough evidence to support the claim that with this method, the probability of being a baby being a boy is greater than 0.5. And I can stick a 0 in there because it does. And we just did that hypothesis test. Done. Next. Actually, TI. It's again one prop Z test, number 5. P was 0.5, X was 39, N is 51. It's a right tail. Calculate 3.78 for our test statistic. All right. So, and then our p-value, if we're doing that, is decimal followed by 4 zeros and then an 8. So that's smaller than our alpha, so we know to reject the null right there. But again, that's going to be next time. So from there, we can get our test statistic. Then we can do inverse norm to find our critical values. 0.01. 2.33. And there we are. Same steps from there. Plot it and see if it's in that critical region, the rejection region. I think we have one more. Yes, we do. Okay, Gallup poll. Let's talk about those for a second. Gallup is a company that is paid to 2 poles, so you can consider those random samples. So if you remember the conditions, there has to be a random sample. N times P has to be greater than or equal to 5, and N times Q has to be greater than or equal to 5. 39 is greater than or equal to 5, and the Q hat would be 12, so that's greater than 5. So we're good. Same thing here, 22% smoke through, that's the smaller number. 22% of 1,000 is definitely bigger than 5. So moving on. Write down what we know. Gallup poll of 1,018 adults. Excuse me 1 second, let me see who wanted what. Okay, so yes, Joffrey, you didn't send me an email, that's why I didn't send you an email. I'll get you after this video. It was found that 22% smoked cigarettes, so that's our P hat. TI users, again, you're going to have to round here. 22% of 1,018 is what X is. Alpha, 0.05. So now we have our claim. That's 25% of adults that smoked last week. And we didn't actually answer the last question now, did we? It says, does this method appear to work? Yes, it does. What the conclusion says, so we can go ahead and answer this one without doing any work. Yes, if we use some non-random sample of a internet survey where it was a voluntary response, we'd be like, yeah, we can't use this data, move on. So Gallup polls are random sample. Surveys that are voluntary are not a random sample. So can't use those, we can use Gallup polls. Let's write down our hypotheses. Claim that less than 25%. Okay, that doesn't have equality in it. So there are my null and alternative hypotheses, and our claim is in the alternative. A lot of times it will be. Okay, so that means P is 0.25 and Q is 0.75. Same process, find the test statistic, find the critical values, graph it, see what's going on. So let me go ahead and grab the test statistic. 0.22 minus 0.25 over square root. Again, this is just using our formula sheet right here. Excuse me. P, I'm going to go ahead and use it, times Q over N. Type it in, see what we get. So we've got 0.22 minus 0.25 over square root of 0.25 times 0.75 over 1,018. Test statistic of negative 2.2105. So we'll call that, 0.5. Why not? All right. Now it's also a left tail. Looking at our alternative hypothesis there. So that means we're going to look up alpha, down cut it in half, and use the negative. And 0.05 is a nice one. right here, negative 1.645. And that's why I like to go 4 decimal places, because sometimes, don't know you, the critical values are 3 decimal places. So if we have 4 decimal places, even if this was, let's say, 1.6453 or 1.6447, we'd know whether or not it was rejected. It's far away, so we don't have to worry about that. Just got to graph it and see what's going on. All right. So negative 1.645, there's my critical value. This is my rejection region. If I have my critical, my test statistic in this rejection region, we reject the null. So I'm going to plot my test statistic in red, and let's see, negative 2.2. That passed negative 1.6 right here. So we're in the rejection region, so we're going to reject the null. Dang it. So we can write down our conclusion. We rejected the null. The claim is in the alternative. There is enough evidence to support the claim that, and then we read the claim, less than 25% of adults have smoked within the past week. And that's it. We're done with the hypothesis test. So TI users, again, you just type in the info, 1018 times 0.22, 223.96, round up to 224. You round properly, not up or down. So 224 is our X. So P was 0.25. X, I already forgot. Okay, so we're going to use 224. N was 1018. And this time we had a left tail. And the only thing that this changes for these tests is our p-value, which we're going to talk about tomorrow again, not today. But we get the test statistic, negative 2.21. If we round it, same thing. If we go to 2 decimal places, it's the same. So we get our test statistics in the calculator, look up the critical values on the chart, or use an inverse norm. For 0.05, and we get negative 1.645. There it is. So we sketch it, see that it's in the rejection region, reject the null, claims in the alternative, we reject the null, there's enough evidence to support the claim. And we're done. That's how you do a hypothesis test. So on Thursday, instead of just going to go over the homework, we're going to actually have a Zoom meeting, and I'll discuss homework problems and any questions you may have. That's it for today. Have a good one.